Our objectives for today's lesson: illustrates percentiles, solve problems involving percentiles, interpret percentiles. Now let's start. Percentiles are the 99 score points which divide a distribution into 100 equal parts, so that each part represents the dataset. The percentiles determine the value of 1%, 2%, and so on, and 99% of the data. For example, P sub 30 or 30th percentile of the data means 30% of the data have values less than or equal to P sub 30. To calculate the percentiles for ungrouped data, we use the formula P sub k equals k times the quantity of n plus 1 over 100 value. So k here is the kth percentile and n is the number of data. Let us deal with the first example. Find the 30th and 60th percentiles of the following test scores of a random sample of 10 students. So first, we need to arrange the data into lowest to highest. And then, we count the number of data, or n, which is 9. Now, we are ready to solve for the P sub 30 or the 30th percentile using the formula. We simply substitute the value of k and n into the equation. So we have here 31st, we have to copy that and then work on the parenthesis, which is 9 plus 1, which is 10, divided by 100, and that is 0.1. Then we multiply, we have 3. So it means that we are going to locate the third value, and the third value in the given data set is 20. So P sub 30 is 20. Now for the 60th percentile, same, we are going to substitute the value of k and n, copy 60, and then work on the parenthesis. We have 0.1. Multiplying, we have 6. So the sixth value in the given data set is 28. That is why P sub 60 or the 60th percentile is equal to 28. Let's proceed to the second example. Find the 20th and 85th percentiles of the following test scores of a random sample of 10 students. So first, again, we need to arrange the scores from lowest to the highest. And then count the number of n or the data, which is 10. Then we substitute it into the formula. So we're going to work on the P sub 21st or the 20th percentile. So substitute the value of k and n into the equation. So copy 20 and then work on the parenthesis, which is 10 plus 1, 11 divided by 100, and that is 0.11. Then we multiply 20 times 0.11, and that is 2.2. So we're going to locate the second and the third value in the given data set, and that is 23 and 24. Now we're going to subtract the third and the second value. We have 24 minus 23, and that is 1. And then we are going to multiply 1 by the decimal part of P sub 20, which is 0.2. So the value here is 0.2. Now for the last step, we need to add the result to the second value, and the second value is 23. So we add 23 plus 0.2. So the answer here is 23.2. So it means that the 20th percentile is 23.2. Now let's solve for the 85th percentile. So again, we will be substituting the value of k and n to the equation. So copy 85 and then work on with the parenthesis, which is 10 plus 1, 11 divided by 100, and that will give you 0.11. And then we multiply, and we have 9.35. So we're going to locate here the 9th and the 10th value, and that is 29 and 30. So the next step is we're going to subtract the 10th and the 9th value. So 30 minus 29, we have 1. And then we need to multiply it to 0.35, which is the decimal part of P sub 85. And then it will give us the result of 0.35. Now we're going to add the result to the ninth value, and the ninth value is 29. So 29 plus 0.35, it will give us 29.35. So it means that the 85th percentile is 29.35. Let us now deal in solving for the percentiles of group data. So we will be using the formula P sub k equals the LB plus the quantity of k times n divided 100 minus CF sub b all over F sub b sub k times I. So here LB is the lower boundary of the P sub k class, and is the total frequency. CF sub b is the cumulative frequency of the class before the P sub k class, and F sub p sub k is the frequency of the P sub k class, and I here is the class size, and k is the n percentile. So k here are the values 1, 2, 3, up to 99. Now let us deal with this example. Calculate the 32nd and 65th percentiles for the following distribution. So first, we need to insert two columns for the lower boundaries and the less than cumulative frequencies. And we know that lower boundaries, these are values that obtained by subtracting zero point 0.5 from the lower limit of each class intervals. And the less than cumulative frequencies, this one is obtained by copying first the frequency of the lowest class interval. So that is 4. 4 plus 9, 13. 13 plus 13, we have 26. So plus 11, we have 37. Plus 7, we have 44. Plus 10, we have 54. Plus 6, we have 60. Plus 12, we have 72. Plus 8, we have 80. So from the less than cumulative frequencies, we can note that this interval contains the first to fourth score. This one contains 5th to 13th score. This one contains 14th to 26th score. This one is 27th to 37th score. This one is 38th to 44th score. This one contains 45th to 54th score. This one contains 55th to 60th score. This one contains 61st to 72nd score. And the last one is 73rd to 80th score. Now we are ready to solve for the P sub 32 or the 32nd percentile. So we need to locate first the interval of the 32nd percentiles, and that would be done using the formula k times n divide 100. Substitute the value of k and n to the equation. We have 32 times 80 divide 100, and that is 2560 divide 100, which is equal to 25.6. So we need to locate which interval does 25.6 belongs. So it belongs to this interval, 91 to 100, since this interval contains 14 to 26 score. So we note that this one is our P sub 32 class interval. Now we are ready to identify the lower boundary, which is 90.5, and which is 80, CF sub b, or the cumulative frequency before the P sub 32, which is 13, and then frequency of the P sub 32, which is 13. I is the class size, we have 10. Now, we substitute all the values to the formula. That's why we have here 90.2 plus the quantity of 25.6 minus 13 over 13 times 10. So using our calculators, we work on the parentheses first. 25.6 minus 13 divided by 13 times 10 plus 90.2, and that will give us 99.89. So it means that 32% of the population have a score less than or equal to 99.89. Now let's proceed in solving for the 65th percentile. So we need to use first the formula k times n divide 100. Substitute the value of k, which is 65, and n, which is 80, divided by 100. It will give us 5,200 divide 100, which is 52. So we're going to locate the 52nd score in the given distribution, and that one belongs to 121 to 130 class interval. So in here, we need to mark this as our P sub 65. So the lower boundary is 120.5 and N is 80, and the cumulative frequency before the P sub 65 is 44. Frequency of the P sub 65 is 10. The class size is 10. Now we're going to substitute to the formula. So we have here 120.5 plus the quantity of 52 minus 44 divide 10 times 10. So it will give us 128.5. So it means that 65% of the population have a score less than or equal to 128.5. Try doing this on your own. Until our next session, thank you and enjoy learning.